Hello and welcome back. Today I have a new device from UNI-T. It is a clamp multimeter and it's the UT207B, and it is a borrow from the dealership, so thank you for that. It was a request from one of my viewers from Eastern Europe, if I am correct. And I actually didn't know about this device. I just thought, nice, it's a clamp multimeter, let's try. So I asked dealership, can I borrow that from you? And luckily they said yes, so it is here. But when it arrived, I thought, my God, this is big. When we look at the box, we already see, okay, it's quite big. This is a standard mock size. Why is it so big? Well, it can go up to 1000 amps through RMS. We have the 207B right here. They say high voltage frequency measurements. You can have a flexible probe also if you want for high currents. Low impedance mode, so if you're measuring AC voltage and there is some distortion on the line, you switch it to low impedance and then it is less effective. Low pass filter, inrush current, that's interesting, we can try that. And function retention, I think that is maybe logging. It has a flashlight right there. They do this very nice. I like that. You can even put it on your tool belt if you like, so you don't drop it if you climb a ladder or things like that. Manual batteries. Look at this. Well, I have small hands, but still it is large. It comes even with probes. Well, decent. This is probably again for the 1600. Okay, let's focus on the device itself. Let's see what we have here on the selector. We have the low impedance mode. It is the off setting to really switch it off, but it has also power, auto power off, AC current, DC current, AC voltage, DC voltage. We have here diode, capacitors, continuity, and resistance. We have here frequency and duty cycle and the non-contact voltage detection and the flashlight right here. The display itself, it is 6000 counts. It has a bar chart also, and well, we can see clearly in what mode we are. Underneath the display we have the selector. That is if you have multiple functions under your dial. Long push is then the low pass filter. We have a relative mode. To set your zero, we have your hold button and the backlight. It's auto ranging, but you can also manual switch it. Here you probably switch from frequency to duty cycle, and a long push is the inrush current, and we have even min-max through RMS. Well, the voltage and all the resistor measurements we do on the bottom right here. Here are two terminals. And the high currents, of course, we do on the clamp. This is the UNI-T. This is the slightly big Fluke 32. And here we have a normal, smaller size. So before I start the test with the high current, inrush current, I like to see the 6000 counts. It does have a bar in the bottom. Is the bar faster than the normal sample rate, which makes it more effective, of course. Let's see, resistors, capacitors, frequency, stuff like that, voltage, and then we start with the high currents. Let's get the DMM check plus. I like to use for this kind of tests. Let's first do DC voltage. Okay, it has been switched on not too long, but we have only 6000 counts, so let's see, it should be exactly 5 volts. Well, let's zoom in a bit. That is not bad at all. Well, it needs to warm a little bit. The bar, can we see how fast it will respond? And if it is faster than the, it seems the same speed. let's do the same for AC. AC voltage. It is indeed true RMS. This is correct. It is a bit lower, but if it wasn't true RMS, then it would have said 5.5 volts. And I think, can I change to hertz also? Yeah, this is 100 hertz, but I can also go to 10k, and then it doesn't do anything. It doesn't even measure frequency. Maybe if I do on this setting, yeah, here it says it's 10k, and I can probably see the duty cycle. Yeah, a little bit off because it should be exactly 50. On the lower frequency, 100 hertz, it does measure exactly that. Yeah. Let's do some capacitors. Let me see. We are now in ohms. We do the ohms first then. It should be 100, close to 100. Yes, that is correct. 1000, 1k, 10k, and 100k. There it is. Continuity. Well, that would be nice to try. This one, I like the LBO2 because it has emulated resistance, and then we can check when the continuity kicks in. So at 100 ohms, no beep. So 40 ohms. Capacitors, let's see. This is diode. Well, we can also try that. Yeah, does that. What is the voltage? We check later. Push again for capacitors, I think. Yeah. Okay. Here we should have 1 nano. Yes, we have 10 nanos. Pretty fast, by the way. 100 and 1 micro sometimes take a little bit. Yeah, it does that. Let's try the non-contact voltage detection. The backlight, yeah, bright. Okay, we have here a cable that has been powered, and yeah, that works. I want to have a look at that bar again, if it's really slow or not. I will put some backlight. I think we can see better. It is here in the bottom, so I will just change it up. It looks like it is exactly the same sample suite. Bloop, switches over to the next range. Doesn't look like the bar is faster. Let's see the min max. We are now on 3.3 volts. We push the button now, and I will go up, 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 and I will go down, down, down. We don't see the display go down, but we do see the bar go down. So the bar is now showing the min. And the display showing the max. Can I switch that? Now we show the, yeah, the current is 4 and this is the min. So if I go up, we see the bar go up and the min stays the minimum. Oh, pretty cool. And to reset, bloop, What I like, by the way, is that the backlight doesn't switch off very quick. I didn't have any problems. I just thought, oh wait, it's still on. So I don't know what is the timeout, but it is long enough even for doing tests like this. So that's a positive thing. Yeah, well, big surprise. It works like a normal multimeter and all the functions work good. Let's do some inrush current. Well, to measure the AC current, I don't have a fancy device or adapter. What I have, I just have a cable here, and I just took one out, and I will put the clamp on that, because if we measure on both, they will cancel out each other. So it will be just this cable, and well, inrush current, that is the max peak that you get when you start an electric motor. And those peaks can be quite high. To measure that, I don't have a special calibrated electromotor. I will be using my dust extractor, aka vacuum cleaner. Well, I have here my AC/DC electrical parameter tester. I can connect here a power supply, and then we can calculate, or it will calculate the efficiency. We're not going to use that now, but we can see the voltage here. Well, it's sunny outside, a lot of solar panels, so the voltage is quite high today, 50 Hz. But these are all distractions. It is about the meter here. So we put it in between, and then we do AC current. Then we need to do a long push here for inrush. Yeah, we can see here it is on inrush. I will put my vacuum cleaner on the lowest setting and then start it. So while this one was around 4 with no more normal operation, the startup was 11 and a bit inrush current, which is quite a bit. I do again inrush, and I put now the dust extractor in full power. We can see that the inrush is now a lot higher. It's almost 24 amps, but because the peak is so short, we cannot see it here. We can only see it with a special inrush. And when we just long push, we can see the normal again. Okay, that was quite nice. You could really see the peak in startup of the vacuum cleaner, and during normal operation you could see that both the meters agreed. Now I'd like to go a little bit higher, because this clamp multimeter can go up to 1000 amps. Well, 1000 amps will be a little bit of a challenge to test here in the lab, but I do have a 40 amp power supply and a 40 amp electronic load, so let's start with that. See what we can do. Well, I have here my Corrad electronic load, 1500 watts, goes up to 40 amps. So let's play a little bit with that. Start with 1 amp. This power supply can also deliver around 40 amps. So I don't know, I just set it to 5 volt. I don't think the voltage matters too much, it's just the current that it is measuring. So I set it to 5 volts. Let's connect. It's all connected. Power supply here, 5 volts, can deliver up to 40. I have here my electronic load set to 1 amp. 2 cables, both go directly. It is 10 AWG, so we can do quite some current. I think it's 6 or 7 squares. And we'll just do it. But it's important we do only 1 wire. And we need to set it to DC amps, so I will just switch it on. I think you can read the display. It somehow already says minus 0.5. Don't know why, but I will just use the relative mode. 1 wire through, and let's switch it on. Yeah, here we have it, 1 amp. Let's go a bit higher. 2, 3, to 5, 5, 4.9, 4.96, go to 10 amps, should be able to do that on 9, missed a click, can we see it? Yeah, okay, well let's go much more, 20 amps, 19, still good, good. 30 amps, no noise. Oh, there goes my electronic load. So 40 amps, no problem at all. The scale was nice, you could see enough digits. And then I'm thinking, I want to test closer to the 1000 amps, but having 40 amps power supply in your lab is already a big thing. I do have 60 amps also here. It's another power supply from Jetphone. And I do have my ease tester, which weird enough goes up to 60 amps. And it works. It's only for 400 watts, but if I keep it around 5 volts, it should be possible. But then instead of 40, we do 60. And yeah, that's not even close to 1000 that we can do. So then I looked on the internet about calibration labs. How do they do that? And I found these pictures. Okay, that's pretty cool device. It's from Fluke. I could see the type number. So let's have a look on the second-hand market. Oof, second-hand, the prices are crazy for that thing. But when you look at the coil, I'm actually thinking, reminds me of a toy. Okay, so that means if you make a coil, each extra winding will give you an extra readout. So let's put that to the test. Okay, so let's try that again. I put again in the cable, I put it on 10 amps. Here we go. 10 amps. So what happens then if we do again? Look at that, then we have 20. So if we do this multiple times, we can measure a lot more than we see, because it says 20 here and it says 10 here. So that means I need a lot of these windings. So all these windings can amplify the readout. So if you have one winding, you have so straight through, you have one readout. If you do it 1 times more, it is already twice the readout. And if you do 10, it will be 10. But instead of buying this toy, because it doesn't have isolation, and I'm not sure if they short circuit, of course you lose that, because it all works on induction, the clamp and the windings, just like a transformer. So what I have is toilet paper roll and some wire. So what I fabricated is this. Don't mind the color, but this is just, I think it's 1 or 1.5 square, so we cannot run too much. But shortly 10 amps is probably possible. I did exactly 10 windings, so straight through would be 1. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, well it's 10. And so you need to put your clamp exactly in between these, because here we have exactly the 10. So that would be like this. So let's have a try. Okay, so I'm doing 1 amp on the electronic load. We can see here. So if I measure like this, we have 1. We indeed have. And if I measure here, we have 10. And I didn't change anything, so it's exactly 10 here, 10.04. And here we have 1. So that's how we can do that. Because I use this thin wire, this is of course not ideal. I can go up to 10, which gives us then 100 amp. So let me switch it on. We have 10 amp here. Probably it will say around 10 here, and here we should say already 100. Look at that, 100.5 amps. But I cannot do this times 10 because I cannot run 100 amps to this wire. So that is pretty cool, and we didn't need to buy this very expensive flue calibrator thing. Of course, this is not enough because I need to go higher. So what about if we take thicker wire? Again, don't mind the color. I bought this because this is the solar panel electrical ground wires, and it's not that expensive, but it is 6 squares, and it's actually good. I think that is close to this AWG8, if I'm correct. And I did 20 windings instead of 10, so that means with 50 amps we should be able to read out 1000 amp. So again, it looks a lot bigger. I used the same toilet paper roll. And instead of using 1 square, I have 6 square here. It's a lot more heavy. I did 20. So 10 this direction and 10 direction back. And well, same, you need to put the clamp exactly here. And well, it's quite heavy, using a lot of scotch to keep it all in place. But and it is very important that it does close. So if we use it, it needs to be perfectly closed to have a good readout, but it fits exactly. So let's try that. So I need 50 amps, so that means I cannot use the cow rod or the Kumkin or the Tenma here because they are all below. The only one I have that can do 60, that is here, the East tester. Only 400 watts, but on 5 volts it should be able to do that. I have here another headphone. It was not that clean for hand use, but as for tests like this it's great because it can go up to 60 amps. So that's also enough, and I have my huge coil here. So let's start with 10 amps. And then we should read nicely 10, and when we go through the coil it should say 200. Let's see if it's possible. We have the power supply here, 5 volts. Set this one to DC current. Wait until it is relative. Lights on. I set it to 10 amp. 10 amps. 10 amps here. Let's see how is the readout. We read about 10 amps in the display here, and through the coil then, when it closes properly, look at that, 200. So now we can go higher. I hope I can hold it and reach everything. Let's go to 20 amps then. Then it says 400 amps. So then we can go a lot higher also. 30, 40, 50 amps we have here, and we are reading 1000 amps. Woo! That was pretty cool. We could read out 1000 amps and we only needed 50 to do it. With a bit of toilet paper, a lot of scotch and some wire, and it worked. The meter looks really solid. I like the clamp. It's good that it is this big also. The, how you call it, the fork or the clamp itself. It's big enough, because if I would have the smaller here, like the fluke, I could not even fit my coil in, I think. No, it doesn't close, so I should have changed my design then, and clearly I cannot do it with this. There are some other home builders that did it exactly different. One also used a coil, and another user was a bit smarter. He made it square, so then the big one can go vertical while you do the small ones horizontal, which is actually a lot smarter than what I built here. So that's it. Thank you for watching, and hope to see you next time.